All right, this video we're going to look at higher order derivatives, and we're going to basically do kind of the key examples that you'll expect to see going forward. Okay, so for standard differentiation, let's come up with an example function for that. Let's just say x cubed plus 3x squared plus 2. F of x is equal to this. So our first derivative, pretty straightforward, 3x squared plus 6x plus 0. Second derivative, just the derivative of this function above, so 6x plus 6. If I wanted to do a third derivative, that would be nice and straightforward too. That would be 6. If I wanted to do the fourth derivative, once we get above about 3, you'll also see this notation f4 of x. 0, fifth derivative, and onwards, it's nice and easy because it's always 0. For polynomials, you'll always tend to get this result in that it zeroes out eventually. If I had something like f of x is equal to sine of x, we wouldn't necessarily see that, because f prime of x would be cosine of x. F second derivative would be negative sine of x. The third derivative would be negative cosine of x. The fourth derivative would be sine of x again. And this will actually cycle through. E to the x, they'd obviously all be the same. But this is where I'm saying that standard functions, they're pretty straightforward, hopefully pretty easy to see what's going on here. Implicit differentiation, as I said before, is a little bit trickier. So I'm going to make up a function, and hopefully it works out well for us to see things here. Let's say that that's equal to y to the fourth. Okay, implicit differentiation. Let's work the first step. So I'm going to get 3x squared times y squared, because I'm doing the product rule. So I take the derivative of the first term, or first function times the second function, and then the derivative of the second function, which is going to be 2y y prime times x cubed. Derivative of e to the x is just e to the x. Derivative of 3 is 0. Then we got 4 y cubed, y prime. Now I need to isolate the y prime. Let's do that on the right side. So 3x squared, y squared plus e to the x is equal to 4y cubed, y prime minus 2x cubed, y prime. So my y prime is equal to 3x squared, y squared plus e to the x divided by, and this is going to be a mess, I shouldn't have done it this way, but we're stuck with our decisions, 4y cubed minus 2x cubed y. So here is our derivative. Now, to take the second derivative, we just do the derivative of the first derivative. This is why solving like this is nice, because the left side becomes quite easy. It's just y double prime. The right side, unfortunately, because of my decisions, are not quite so friendly. So it's the derivative of the top expression, which is going to be 6xy squared plus 2y y prime times 3x squared plus e to the x. So that was the derivative of the top term, times, I'll just write the denominator in here for saving us some space, and minus the derivative of the denominator, which is a little bit cleaner, 12y squared. Uh-oh, I did not have a box here, so I've gone under my face. So let's rewrite that here. Y double prime is 6xy squared plus 2y y prime 3x squared plus e to the x times the denominator minus 12y squared minus 6x squared times y plus y prime times 2x cubed. All of that times the numerator, all over 4y cubed minus 2x cubed y, quantity squared. Now you'll notice in this expression I have a y prime here when I took that derivative. What I would need to do is take this right here and plug it in here before I get my final answer. So that way my y prime only has x's and y's in it. I'm not going to do that because I chose a bad example and I've made a mess of it, but hopefully you kind of see the logic. What that will end up doing is that means that as you continue to take higher order derivatives, you'll continue to just get first order y primes, and it ends up being very straightforward to take the derivative. I chose a bad example for kind of the math that you'll do. If you do some practice problems, you'll get much cleaner, much nicer examples to work with. The mastery check will be a much cleaner example to work with. So don't stress too much about it. I just want you to follow the major strokes of it. I did the standard derivative. Then it became easy to get the second derivative by having the derivative of the left-hand side. The right-hand side was a mess. Did result in some y primes, but that's okay because, oh, sorry, there's another place that y prime showed up. Over there. But what I ended up doing then is taking the first derivative, plugging it in. When you do the third derivative, if you were to do the third derivative, you would still only ever get y primes. You wouldn't get y double primes. So it's always just going back to this function here, plugging it in at the end. Let me know what questions you have, but otherwise that will wrap us up here.